Hi there, we are QF-6 today, the zeros of a quadratic. Okay, so we have seen a lot to do with quadratics as of recently. We have been identifying the zeros, we've been looking at parabolas and turning points and axis of symmetry and shifting a parabola. And the last thing we're going to be talking about with parabolas is something that we're going to do for actually solving them algebraically. Okay, so just to be reminded, our standard form is y equals ax squared plus bx plus c, where a, b, and c are all just regular old numbers. A tells us the graph shape, so if A is positive, positive people smile, and if A is negative, negative people frown. Okay, so we're talking about concavity, so if A is positive, we're concave up. If A is negative, we're concave down. And this C value tells you your y-intercept, okay? That's where it crosses the y-axis. All of this together gives you a quadratic. All right, now factored form. We have done a lot of factoring already. We did it when we first learned factoring, and we did it when we completed the square. A still tells us the graph shape, so it's still concave up if it's positive, concave down if it's negative. But what we're going to see here is that M and N represents the zeros. Okay, we also call these the roots or the x-intercepts. Okay, it's where this function crosses the x-axis. Okay, so that's what that means. All right, it's where they cross the x-axis. We're going to jump right into an example, and it says consider the quadratic function y equals x squared minus 2x minus 3 right here. So the first thing we should just talk about really quick is, what are we looking at? Well, A is positive because I have a positive 1 in front, so that means I'm concave up, I'm smiling, and my y-intercept is negative 3, so that means that this parabola should be crossing at negative 3, which it does. Okay, so just to verify that that's the parabola we're looking at. What are the zeros of the function? Write their x values and circle them on a graph. Okay, so the zeros, the M and N represent the zeros, or where I cross the x-axis. So where do I cross the x-axis? Well, here's my x-axis. I cross right here, and I cross right here. So these two things, these are my zeros. Okay, and I don't really care about the ordered pair. What I care about mostly is their x value, because their y value is 0. So on this side, I start at 0 and I'm going to the left 1. X equals negative 1 is one of my zeros. If I start at 0 and go 1, 2, 3, x equals 3. Okay, so I have 2 zeros because my graph crosses the axis 2 times, and also this quadratic has the biggest exponent of 2, so that usually has something to do with it. So verify that the positive 0 is correct by showing that y equals 0. Okay, so this is the negative 0 because it's a negative number. This is the positive 0 because it's a positive number. So what we're going to do here is plug this into our equation and show you that this actually equals 0. We're just basically checking. So I'm going to have 3 squared minus 2 times 3 minus 3. And what I'm trying to do is see if this thing equals 0. Okay, well, let's put it in the calculator. Okay, so I get parenthesis 3. Make sure that anytime you're plugging anything in, you're going to use a parenthesis. Minus 2, I'm plugging in another 3, so I'm going to use a parenthesis. Minus 3, 0. Okay, so 0 equals 0. And since this is a true statement, remember that this is a solution. Okay, so I just verified that that is a 0. And the input of 3 gives an output of 0. So if your y value is 0, you're going to have a root at that x that you plugged in. Factor the expression x squared minus 2x minus 3. How do these factors compare to the zeros? Okay, so factoring, remember, anytime that you're asked to factor, you're going to do an x method. Okay, the X method where your B is at the bottom. So this is the B for bottom, so -2. And your C is this one up here, which is -3. Okay, and what I'm looking for are two numbers that multiply to give me -3, but add to give me -2. Okay, well, that'll be interesting. So I have 3. I have 1 and 3. That's going to be it. Okay. I need -2 and -3. So when I multiply these two things together, one of these have to be negative if I'm going to get a negative output. And this one is negative, so that means my bigger number has to be negative because -3 plus 1 is -2, and -3 times 1 is -3. I also could have figured that out here. So the sign on my constant is a negative. That means that my factors have different signs, and this sign in front of your B value is the sign of the bigger number. So what are my factors here? I get x plus 1, x minus 3. Okay, so these two things are equivalent. This is factored form, just like this, factored form, and this is standard form. So this is my standard form. Same thing, just look a little different. This is going to help us more because how do these factors compare to the zeros? Well, remember what my zeros were. I had x equals -1 and x equals 3. Okay, well, how do they compare with these? Well, in this set of parentheses, I have x plus 1, but this says -1. And then here I have x minus 1, but this is +3. So the factors have opposite signs of the roots. AKA zeros. Okay. So what does that mean? It means that this right here is a factor. If I wanted to call this a zero, the zero would have the opposite sign of what's inside of here. Just like when we talked about shifting. But why does that happen? Okay. Well, when we are actually getting to solving these things, the first thing we learn about is something called the zero product law. Okay. If two or more quantities have a zero or have a product of zero, then at least one of them must be equal to zero. In symbolic form, A times B equals zero, then either A has to be zero or B have to be zero or both have to be zero. Okay. Because what happens here is that if you have anything times zero, so 10 times 0 is going to give you 0, right? So whatever you have, if you're multiplying to get an output of 0, one of these things actually has to be 0 if you're going to get an output of 0. And that's what this product law says, okay? So how do we use the product law? It's very simple, okay? So we're going to use the product law to find all solutions to each of the following equations. What you have here is a product. I have x plus 7 being multiplied by the quantity x minus 2. So the product, the zero product law says is that if you have a product of 0, this has to be 0 or this has to be 0 because that's the only way if you multiply these together you're going to get 0. So how we do that mathematically is we put a little table right here, okay? A little T-chart. And what we say is that if I'm going to get a product of 0, this one has to be equal to 0, or this one has to be equal to 0. Okay. One of these things have to be equal to 0 if I'm going to get an output of 0 as a product. And now all we do is just solve. So -7 minus 7, x comes down, and I get x equals -7. Okay, so basically what I'm trying to do is find what value of x is going to actually give me a 0, okay? So plus 2 here. Bring this down. I get x plus 2. Alrighty, so basically what we're saying is that x equals -7 and x equals 2. These are the zeros of the function. Okay, these are your zeros. Okay, same thing. So when we do get to solving, this is the complete last step normally. This is where you would actually stop that whole line of solving, okay? So what do I have here? I have quantity 2x minus 1 times quantity 3x plus 4. All of this equals 0. I want to know the zeros, okay? So the zero product law says if this product is going to equal 0, either this one has to equal 0 or this one has to equal 0. Okay, and now I'm just going to solve for x. So if I want to solve for x, I'm going to cover it. And the first thing it says is -1. So I want to move that to the opposite side of the equation. So I use the opposite sign. Okay, 2x has to come down. The 1's canceled, and 0 plus 1 is 1. Okay, I'm going to now, I have 2 times x. To undo times, I divide. So divide 2. And I get x, I'm going to squeeze it in here, equals 1/2. Okay, so basically what I'm saying here is that if I put x into this equation as 1/2, it's going to equal 0. Okay, so this is a 0. This is a 0. For the next 0, solve for x, so -4. Okay, I can bring down this 3x, 4 cancels, and 0 minus 4 is -4. Divide by 3, and I get x equals -4/3. Okay, so these are my zeros. Those are the zeros of my equation using the zero product law. All right, so just a bunch of examples, a few different techniques that we have learned through a couple of units, okay? So find the roots, the solutions to each of the following equations by the zero product law. Sometimes you will be instructed to solve by factoring. Okay, well, we have a few different techniques now. We have factoring completely, we have completing the square, we have greatest common factor, okay? So the first thing you should always do is see if you can take out a greatest common factor, okay? So I have x squared plus 4x minus 12. Can I take out any numbers? Well, the smallest number is a 1, so that would be useless, okay? So I can't take out any numbers. What about any letters? So I get x squared, so this one has 2 x's to give. This one has 1 to give. This one has none to give. So that means I can't take out any GCF. So now let's go to factoring, because factoring would be my next choice. So if I was factoring this, I'm going to use the x method. Okay, and remember this is your B and this is your C. B stands for bottom and C stands for top. Okay, and I'm looking for two numbers that multiply to give me positive or -12 and add to give me 4. Okay, well, let's think. I have 12. I have 1 and 12. I have 2 and 6. And I have 3 and 4. 1 and 12 is not going to work. I'm not going to get 4. Oh, look at this. 6 and 2. So that's certainly going to give me 4. Okay. And I need the 4 to be positive. So that means that this 2 is negative. So 6 minus 2 is 4. 6 times -2 is -12. I could have looked at it here. The C has a minus on it. That means that they're going to have different signs. The B is positive, so that means the bigger number is positive. So what are my factors? Well, my factors are x minus 2, x plus 6. All of this equals 0. All right, so this is the last step. This is the zero product law. So what x values is the solution? So I have to now solve for x using the zero product law. So if this is going to give me an output of 0, it means x minus 2 has to equal 0, or x plus 6 has to equal 0. And now I just solve. So plus 2, and I get x to come down. This cancels, and I get x equals 2. Okay, last one here. So cover x, it says plus 6. To move it to the opposite side, I have to use the opposite sign. X comes down, 6 cancels, and 0 minus 6 is minus 6. So what are my roots? My roots are x equals 2 and x equals negative 6. That's your solution. All right, so for B, let's talk about the same thing that we just did. Can I take out any numbers and letters? GCFs always come first. So 2 can go into 2 for sure. Can 2 go into 14 evenly? It definitely can. So 2. All righty. This has 2 x's to give. And this has 1, so that means I can steal 1. Can factor out an x. Excellent. All right, so I've taken out my GCF. And what am I left with inside? So 2 divided by 2 is 1. I stole one of the x's from this thing, so that means what's left inside is just an x. Minus is the operation. Negative 14 divided by 2 is 7. I took the x from this one, so there's no x on that one. And it's equal to 0. All right, is this the zero product law? It sure is, because I have 2x times the quantity x minus 7. If this is going to give you an output of 0, one of these things, either 2x has to equal 0 or x minus 7 has to equal 0. And now I just solve. So 2 is being multiplied by x. To undo multiplication, you divide. Okay, well, what is 0 divided by 2? Can you break 0 up into 2 pieces? No, you cannot. So you just get x equals 0. All right, over here, I see minus 7, so I'm going to add 7. And I get x equals 7. Those are your roots. X equals 0, x equals 7. Okay, so x squared minus 25. GCF can no, because this one has a leading coefficient of 1. Any x's? No. Okay, so let's talk about factoring. Okay, well, what happens here? Where's my b term, right? This one had a b term where it's just 4x. I'm looking for just that variable that just has the x attached. Well, I don't have one, so it's 0. On the top is minus 25, because that's your c. It's your constant. Okay, well, this works just fine. I need 2 numbers that multiply to give me negative 25, and they also have to add to give me 0. Okay, so if I had 25, I have 1 and 25, 2 no, 3 no, 4 no, 5 and 5. Okay. 5 and 5. Well, if these things are going to add to give me 0, one of these things has to be negative. Okay, so negative 5 times 5 is negative 25. Negative 5 plus 5 is 0. So what are my factors? I get x minus 5, x plus 5 equals 0. Okay, so if I want to actually solve for the zeros, it says that if you're going to have an output of 0, either x minus 5 has to equal 0 or x plus 5 has to equal 0. Okay, so I'm going to cover this and undo what I see. So I say plus 5 on both sides. X gets to come down, and I get x equals 5. Okay, minus 5. X gets to come down, cancels this, and 0 minus 5 is minus 5. Excellent. Okay, so again, these are my zeros. My zeros are where, remember what my zeros are. They're where it's crossing the x-axis. So this parabola crosses the x-axis at 5 and -5. This one will cross at 2 and -6. This one will cross at 0 and 7, okay? All right, this is gonna be the last one with the zero product law here in this little section. So first thing I'm gonna do is try and figure out if I can pull out a greatest common factor. So 3 goes into 3. Does 3 go into 6? Yes. Does 3 go into 24? Absolutely. So I can take out a 3. Can I take out any letters? So this has 2 x's to give me. This has 1. This has none. So that means I can't actually take out any x's. Okay. So I have 3 divided by 3, which is 1. And then I have an x squared hanging out here. Minus is the operation. 6 divided by 3 is 2. And I have an x hanging out with that one. And -24 divided by 3 is -8. Okay. Now I want you to be careful here. This is not finished, okay? You still have an x squared term hanging out here. So that means you actually have to factor this thing, okay? Where b goes at the bottom and c goes at the top. And you need two numbers that multiply to give you 8, but add to give you -2. Okay, well, we have 1 and 8. We have 2 and 4, 3 and nothing, so it has to be 2 and 4. Okay. So this is a -c. Your b value is negative. That means your bigger number is negative. So I get -4 plus 2 is -2. -4 plus 2 or times 2, sorry, is -8. Okay. So don't lose that 3. And you have x plus 2, x minus 4. All right. Is this the zero product law? It sure is. I have 3 times quantity x plus 2 times quantity x minus 4. So for this one, I'm going to have 2 lines to separate all of these things. Because if I have an output of 0, either 3 has to equal 0, x plus 2 has to equal 0, or x minus 4 has to equal 0. Does 3 equal 0? No. So this makes no sense. So this is basically just canceled out, okay? Remember what we're doing here is this is like our A value. So this has no bearing on any zeros or anything like that. All right, I'm going to solve this. So -2, x is going to come down, and 0 minus 2 is -2. Okay. I'm going to solve here. So +4, x gets to come down, and 0 plus 4 is 4. Alrighty, so that means that this thing crosses the x-axis at x equals -2 and x equals 4. So now what we're going to do is put this all together, and then that's going to be it. So find the zeros of the quadratic y equals x squared plus 3x minus 10 algebraically. So notice what this says. Algebraically. If you do not show it algebraically, you will not get any credit, okay? When something says algebraically, it means that you have to show your math. Don't just put on the graph this picture because that's not algebraically. It doesn't matter, okay? Okay, so what we're going to do here, I'm going to rewrite this. So I get x squared plus 3x minus 10. Since I'm going to find the zeros, notice how this is a y. If I want to find the zeros, I'm going to set this equal to 0 because the zeros are where y is 0. So if I want to find the 0, this thing has to be set equal to 0. Can I pull out a GCF? No, because 1 is the smallest number, so I wouldn't pull out a 1. What about letters? X squared, x, no x. So no letters can be pulled out either. So let's try and factor this. So this is your B. B stands for bottom, and this is your C. That goes on top. And I'm looking for two numbers that multiply to give me 10, but add to give me 3, or -10, I apologize. I have 1 and 10, 2 and 5, 3, 4, 5, nope. Okay, so I'm not going to get 3 from 1 and 10. It has to be 2 and 5. Okay, so let's see. This number is negative. That means these have different signs. And B is positive. That means the bigger number is positive. So the 2 has to be negative. 5 minus 2 is 3. 5 times negative 2 is negative 10. What are your factors? We get x minus 2, x plus 5 equals 0. Okay, the zero product law says that if you're going to have a product with an output of 0, one of your factors has to be 0 or the other factor has to be 0. So x minus 2 has to equal 0 or x plus 5 have to equal 0. And then I'm just going to solve. So I'm going to say plus 2 on both sides. X gets to come down. 2 minus 2 is 0. And 0 plus 2 is 2. Cover this. Minus 5 on both sides. X gets to come down. 5 minus 5 is 0. And 0 minus 5 is minus 5. Okay, so this x equals 2 and x equals negative 5 are my roots. So let's put this on the graph. So negative 1, negative 2, negative 3, negative 4, negative 5. And then 1, 2. Okay, my y-intercept is negative 10. So 1, 2, 3, 4, 5. Ooh, right down there. I couldn't tell you the turning point or anything like that right now. But let's just put this thing in where y equals so we can get a valid look at what this is. So x squared plus 3x minus 10. Okay, beautiful. I just want to confirm that our zeros are correct. So this 0 is at 2, 2. This one's at 1, 2, 3, 4, 5, negative 5, negative 5. I'm just going to go to second table or second graph, and I'm going to put some more numbers on here. Notice what these look like in the calculator. So your y value at your zeros will be output of 0. So at when x is negative 5, your output is 0. When x is 2, your output is 0. Okay, so let's go between those things. So negative 4, negative 6, negative 3, 10. Well, that's our y-intercept. We knew that. Negative 2, oopsies, negative 3, negative 10. Oh, okay. Sorry, I screwed that up. Negative 2, negative 12. Oh, no. We're off the graph. That's okay. Negative 1, negative 1, negative 12. All right, so we get the idea of what this kind of looks like, though. That's the big idea here. Okay, so that's basically what it's going to kind of look like. I didn't realize that we were going to be off the graph, so no worries. The big idea was this piece right here. This is what they actually wanted us to do. That was just like a visual representation, I guess you would call it. Okay, so I hope you have a wonderful day.